Swayam Prabha. Digital India. Educated India.
Good morning. So, we start about the course. Course is Audio System Engineering, and this course will be mainly deal with that audio systems, not exactly the systems. I will cater this course to more or less acoustic design and that part. So, the course Audio System Engineering, whole course will be covered by 10 hours lectures. Okay. So, if you see that when I think about what is audio system engineering, first we have to think about what is audio. What is audio? If you see that, or you have heard about audio signal, audio is not coming out. So, in audio basically a sound is generated, or sound is a sound wave. Audio wave means sound wave. So, if I discuss what is sound, think about first what is sound. So, what is sound? The sound is a pressure wave which is created by an vibration or vibrating object. You think about, if I strike in the table, a sound is generated. That means, always a sound is created based on some vibration. Without vibration, sound cannot be created. So, source of the sound is vibration. Now, how this sound is travelled to me, how this sound is propagated, then this vibration has to be propagated in some way. So, this vibration, once I strike in this here, the vibration is created. So, this vibration set a particle that if it is vibrating, surrounding particles are moving. So, those movement transport energy from one point to another point. That is why the sound wave is propagating. So, if I think about that sound system engineering, first we have to think what is the source of sound. We said source of sound is nothing but a vibration of a mechanical object, okay, mechanical vibration. Then, so you say how the sound wave is transmitted, that has to be known. So, this course will cover that. If you see this whole course will cover the fundamentals of vibration and how this vibration can be mathematically modeled, that is equivalent electrical circuits, that is sound system engineering. Then how this sound wave is propagated. So, I said sound wave is nothing but a acoustics wave, that the properties of how the mechanical oscillation is propagated in a medium is called acoustics. So, this acoustics wave, how this acoustic wave is propagated in the medium, that is called linear wave acoustics wave equation. That means, we have to derive how acoustics pressure wave or how acoustic energy is travel from one point to another. So, mathematical derivation of those properties is called acoustics wave equation. Now, if you see, maybe is it linear or is it non-linear? So, it may be linear, non-linear, or it may be linear. So, here we restrict ourselves up to linear acoustics wave propagation. Why? If you think that sound generated by a crowded auditorium, the intensity of that sound is still obey the linear wave equation. But if you see the example, explosion of a bomb, instantaneous energy of a bomb explosion is such a way or such huge that it cannot be expressed by a linear acoustics wave equation. So, we are not interested to go there. So, this course is only deal with the linear wave equation and sound wave propagation using that things. So, we are up to interested is that sound propagation up to let us auditorium that or you can say the stadium, packed stadium humming noise, that also huge intensity, but how that is propagated. So, we are talking about that things. Then if those are the sound intensity, think about if I produce a sound here, that sound strike to the wall. Now, how the wall is reflect that sound or how the wall is transmit that sound inside the wall is called sound transmission phenomena. So, we have to know that phenomena also. Suppose practical, for a practical example, that we want to that inside that auditorium should be soundproof from external sound source. That means, suppose I design an auditorium and I should not want the outside sound should come inside and inside sound should go outside. Now, if I want to restrict that things, we have to know phenomena, how sound is transmitted in the medium, how sound is reflected by a medium. So, as you know that any sound or acoustics wave without media cannot transmit, because if it is transmit, then the explosion which is happening that above the earth, that means that we cannot hear it, because in that region there is no medium. So, without medium sound cannot travel, that is why that sound is not coming in our earth. So, we are not getting that sound. So, any acoustics wave if you want to propagate, then it requires a medium. Now, once it is requires a medium, how the wave is propagated in the medium is mathematically described by the wave propagation equation. How that wave is reflected by the medium, transmitted by the medium, absorbed by the medium or attenuated by the medium, that is called sound reflection, transmission, absorption and attenuation. So, if you see in large, now that I know that okay, I know the sound absorption, transmission and attenuation, then what I required, that suppose I want to design a acoustics room or say recording studio, sound you heard about that sound recording studio. If you go to that any in any recording studio where the song is recorded, where that cinema dubbing is happened, if you see the special kind of room, why this special kind of room is required? Why cannot be it is done in here? That means, we want to reduce the, if you see that I produce a sound, if that is that sound I want to record, I should not want that environmental noise should corrupt that sound. So, I want to reduce the environmental noise. If I want to reduce the environmental noise, that means some sort of acoustic treatment I should made in the room, so that external sound should not come inside the room or internal sound should not go outside the room. Okay. Similarly, if you want that, suppose I want to build a huge auditorium. Now, if I speak in the stage, the last row cannot hear it, then we put some microphone. Once I put some microphone, if the auditorium is huge, then there may be a chance of echo. So, I want to reduce the echo, I want to optimize the sound intensity, so that every seat in the auditorium must listen that sound. So, that means, I want to create a sound field inside the auditorium such that the intensity at every point must be more or less equal. Okay. So, that kind of treatment I want. So, those are called large room and small room acoustics. Now, large room acoustics, you heard about that, somebody said you know the reverberation time of this auditorium is 2 seconds. So, what do you mean by reverberation time? As an engineer, I should know what is the physical meaning of reverberation time, how it is calculated for a given specification of an auditorium, of an cinema theatre. If you visit any Dolby Digital Hall, yes, you have many of you visited the Dolby Digital Hall. If you visit Dolby Digital Hall, you see there is some kind of acoustic, there is some kind of particle boards are fixing inside the wall, backside there is a huge blanket is, why it is required? Those things we have to know. So, those things is called acoustics properties of sound room. That may be a large room acoustics, that may be a small room acoustics. If you see very practical example, if I put a microphone without the cover of that sponge cover, what will happen? If you see, it create a burst kind of energy. So, if I want to reduce that energy, suddenly we put a sponge cover just top of the microphone and reduce. How it is reduced? We have to know that things. So, we have to know how the acoustic properties are dealt, how the auditorium is designed, only acoustics part, how the acoustics part of the auditorium is designed. So, that are called architectural acoustics. Even today, think about, I want to design my drawing room to get the feeling of 5.1 channel loudspeaker. You know that 5.1 channel hi-fi music systems. So, I have to know, if I want that 5.1 channel real effect, how do I place my loudspeaker? I buy 5, you know, you have seen that, you have a 5 loudspeaker you have given in 5.1 channel audio systems. Where to put? If I put all in front of me, am I getting that 5.1 channel effect? So, where I put that place that microphone in my drawing room, and what should be the minimum size of the drawing room to get that effect? So, all those things, as an acoustical engineer or sound system engineer, I should know that things. So, those things will understand with this course. So, this course only deal with how to calculate the reverberation time, how to find out the minimum free path, how to find out the various acoustics parameters like intelligibility of the acoustic parameter like percentage alcon, those things how do I find out. So, all those things will deal with this course. So, we will start, we will touch that architectural acoustics. Now, think about why I required a ramp kind of things in auditorium. Forget about the visualization part. Is there any issue in sound part also? Yes, we have made the ramp because of everybody can see the stage, that is one part. Another aspect is that also an effect in sound also. To getting the proper sound in every set, I require a certain kind of ramping. So, that part also we will discuss in architectural acoustics. If I put a two parallel wall in a auditorium, if you see any auditorium does not contain any parallel wall. If you visit to Kalidas auditorium in IIT, or if you visit any hall, a cinema hall anywhere, you see there is no exactly parallel wall. So, why it is not there? There is a acoustical reason. So, those reasons will be discussed in this course. So, we will discuss about the architectural acoustics. Then loudspeaker and microphone design. I will talk about something on basic principle of loudspeaker and microphone design and acoustic transduction. What is acoustic transduction? That means, if you see, you know that if I produce a mechanical sound here, if I want to convert in electrical sound, I put a microphone here. So, what is microphone is doing? It converts that mechanical vibration to electrical signal. Similarly, if I supply an electrical signal to the loudspeaker, it produces an acoustical vibration. So, that means electrical to mechanical vibration. So, this transduction will be discussed, and then we will discuss how those loudspeaker and microphone basically design. What are the different kinds of loudspeaker is available in the markets. As an engineer, somebody told you, sir, this loudspeaker is very good. If you go visit in a audio markets and you see you want to buy a 5.1 channel music system, then they said, see that sir, loudspeaker specification, it is a very good loudspeaker. You heard about the Bose loudspeaker. Why it is very good? What are the characteristics I should look for a good loudspeaker? So, design is one part, another part is be aware about the loudspeaker specification, so that I can say yes, this loudspeaker is technically good. After examining the technical specification, I certify that this loudspeaker is good. Suppose you want to design an acoustic system, audio system for your institute or you want to design seminar room acoustic system. You go to the market and want to buy a loudspeaker. If you buy one loudspeaker, people say, yes, my loudspeaker is good. As an engineer, I should see after the specification, and I should understand each of the meaning of that specification, and then I should certify, yes, this loudspeaker is good. So, we will study about those specifications during the loudspeaker design. Similarly, same case is applicable for microphone also. If you see, somebody showed you, Shure microphone is very good, Bose microphone are very good, and this microphone very costly. I do not know why it is so costly. There is you can find a microphone with 500 rupees and I can find a microphone with 1 lakh rupees. So, what is the difference? So, if I see the specification of the microphone sets, I should understand, as an engineer, I should be able to tell that is why those are the technical point. That is why this microphone is very good for this kind of audio capturing, this microphone is very good for this kind of audio capturing. So, you can certify, you buy this microphone for this purpose, you buy this microphone for this purpose. So, during the microphone design, not only we try to design the microphone, means we should know how the microphone is designed, but also we should understand. If I see the technical sheet of that microphone, I should know each and every point. So, that also will be covered. Then I will touch about the audio system, means amplifier, how the microphone is connected to the amplifier, what are the different kind of connector is available, why this connector of this type. Have you heard about the XLR connector? Then you heard about the RCA connector. So, why those connector are evolved and how why this connector is very good. So, connection diagram, then amplifier, acoustic audio amplifier. You heard about. I did not design that audio amplifier because this is a part of purely electronics engineering. So, I have excluded the design of audio system, audio amplifier, but I should understand, we should understand if a microphone is connected to the audio amplifier, what are the connection point, what are the point I should check for an audio system. So, those things will be discussed. So, this is the more or less coverage of the audio system engineering course. So, first I try to mathematically understand the theory of sound, how the sound wave is generated, how the sound wave is propagated, and then we understand how the sound wave is transmitted in a medium, how it is reflected, absorbed, transmitted, diffracted, all those properties. Then we go for the architectural acoustics, what is large room acoustics, small room acoustics, and what are the acoustics parameters like the reverberation time, mean free path, standing wave, how it is generated, node, all those things, and then we go for the acoustic treatment or acoustic design of an auditorium. So, more or less this course not only beneficiary for the electronics student, but also it is beneficiary for who are studying civil engineering and architecture. Many of time all of you are ignore this point, sometime you ignore that acoustics point of that when you design the architecture. So, if you attend this class, if you know that basic acoustics properties of architectural design, then at least you can apply those things when you design that civil diagram for an auditorium or other things. Okay. So, this is the more or less course coverage. Then if you know the why you study the course, if you see, in my opinion, every course, that why you study the course, only for the credit, that okay, I will earn some 2 credit, 3 credit. No, the purpose of this course is that if you are attending this course, you want to know or you want to develop certain skill on audio system. It is not that you know what is reverberation time. If you do not know how to apply it, then that knowledge does not have any effect. So, if you say the what should be the outcome of this 10-hour courses, after you attending whole 10-hour lecture, assignment, all the examination, what skill as a teacher I look for you, and as a student what skill you want to develop using this course. So, intended skill at the end of the course should be given the specification of an acoustics room. Suppose I provide you a specification of an acoustics room, you should able to determine the reverberation time, mean free path, number of reflection per second, room node, minimum volume for the room acoustics, all the acoustics parameter you should able to calculate if the specification of an acoustics room is given. So, this is the one outcome. So, that means you not only know what is reverberation time or definition of reverberation time, you should able to calculate the reverberation time for a given specification. Okay. Next thing is that given the specification of your auditorium or studio requirement, that suppose somebody give you, I require this kind of auditorium, that many number of seats, that many wattage of maximum sound, and you design that acoustics part of the auditorium. So, as an engineer, I should able to design the acoustics part of the auditorium, what kind of acoustic treatment I should put in the stage, what kind of acoustic treatment I should put on the wall, what I should tell the civil engineer that if you want a good acoustic, you should keep this point before you construct that auditorium. There should not be many parallel wall, there may be this kind of volume. So, all those things you should able to understand and design that auditorium. Okay. Then there is a come about that, okay, I designed the auditorium. How do you measure the auditorium is very good? How do you know the auditorium is, if you see that there is a theatre in London and that day without microphone people can hear, even if you see the acoustics of the Bulbulaya, Lucknow, if you see, if you produce a voice or sound in some portion, it can travel long distance, but generally sound cannot travel. So, they produce the acoustic structure of that monument such a way that sound can travel long distance. Okay. Then you can say, how do you measure the acoustics quality of that auditorium? There is a different kinds of measurement. You heard about the percentage alcon, there may be intelligibility, blendingness of the sound. So, all those parameters I will define in this class, and you should able to apply those knowledge when you design an auditorium. If after this course, if you sit in any auditorium, your mind should create some questions. This auditorium is good this part, this auditorium not good in this part, this can be make good if I do this kind of things. Once your mind is that kind of question is asking, then my course is fulfilled. So, at the end of the course, you should able to make curiosity, or you can also able to find out, okay, this is the acoustics problem. So, let us try to solve this problem. So, able to solve those kind of acoustics problem, then you understand that sound system engineering course. Then we said that given the necessary specification, design the microphone and loudspeaker. This is one part. One part is that I provide a specification. I can say, okay, this microphone can be designed like this way. You may ask, sir, we are not designing any microphone in near future, because we may not be the manufacturing join in the manufacturing industry. Is okay. You are not actually design the microphone, but if you study how to design a microphone, you apparently know if a microphone is given to you and how to read the technical specification of that microphone. What are the meaning of each of the point which is mentioned in the data sheet of a microphone and loudspeaker. So, that is both sides you should be able to do. Either I give you the specification you should design, or I provide you a microphone and the data sheet, you should interpret it each and every point, and you can measure that yes, sensitivity of microphone is claim minus 50 dB. Yes, this microphone is a minus 50 dB, I can measure it by creating this kind of experiment. So, that kind of expertise I want on you when I taught about the specification design of microphone and loudspeaker. Then determine the sound, reflection, transmission, absorption coefficient for a given acoustic source condition. Somebody told you, sir, why I require a concrete wall between the auditorium and the control room? I have put a control room, small control room at that side. I can make a simple partition of a gypsum board. Why I require a concrete wall? So, you have to explain that if you produce a sound in the auditorium, this sound should not go in the next room if I put a concrete wall. So, that means I have to know how the sound wave is transmitted, how the sound wave is transmitted through the concrete, how the sound wave is transmitted to the gypsum board, how the sound wave is transmitted to the any particle board, whatever you are saying. So, those things you have to know, or you have to understand clearly that yes, this way is sound wave transmission. That means, how do you measure the understand? Understand I cannot measure, whether you understand or not things. So, what I give, I provide some sound acoustic source specification. This is the acoustic source. Now, you have to measure how much amount of this acoustic source will be transmitted from one room to another room. So, those are the called the sound reflection, transmission, absorption, and how to find out those coefficient for a given source, given medium, all kind of things I will cover. So, those are the course outcome. So, I believe that nobody, all of you just read that course, okay, and pass the exam. I do not want. Everybody must develop that skill. Yes, I attend the sound system engineering course, and I specifically I have a skill how to measure the reverberation time of an auditorium. Specifically, I have a skill how to find out the transmission coefficient if a sound wave is generated in here and transmission on this medium. And I have a skill, if I have seen the specification of the microphone, I should know which microphone is better and why it is better. And I should able to communicate this thing with my parent organization or with my client, and I should able to explain them as a client side also. Okay. So, those are the skill I want from audio system engineering courses. Okay. So, this is the basic coverage and outcome of the courses. Now, those outcome, those are the course outcome. That means, at the end of the course, those skill I should have. Now, how this course outcome will be fulfilled? Throughout the course, if you attend, one by one outcome I will develop on you. So, it is not that you have to follow my whole lecture like that. If you see that yes, I have already have this outcome, please try to solve that some tutorial which I will provided to you, that if you are able to solve that things, that means you have a little bit of understanding of that things. Now, if you have any doubt that yes sir, I do not understand physically, or without clear on your mind that yes, I have understand everything on these things, you ask questions. So, I will encourage all of you to interact with me or the TA if you have any doubt in any point during my lectures. There may be some error in during my lecture also. It is there, it will be there. There will be some error. I want all of you should, once you watch the video, you should able to identify those error and communicate to me. Yes sir, here is my, I understand there should be some error. Then I should clear that error, and that process you understand, yes, this is the case which I want to explain you. So, that means it is not a one way communication. I just give you some, if you search in the Google design of a microphone and a loudspeaker, you get thousands of pages, enough material. I do not require to supply you the material, but you have to require that within that material, if I read this material, what skill I should develop. So, I want try to develop you some skill, that society give you some problem, can I solve this problem using, if I say that yes, somebody of you asks that yes, have you done that audio system engineering? Yes sir, I have done the audio system engineering course. Then somebody asks you, see that in Kalidas auditorium, I found that sound is not that good, there is some hassy kind of sound system, sound noise is coming out. Then you should able to technically identify what is hassy noise and how it is generated. If you see, many times when you connect a laptop to an amplifier, suddenly a noise is coming, that is one continuous noise is coming. How to solve that noise? How to reduce that noise? And an audio system engineer, I should be able to tell, yes sir, that your laptop ground and this amplifier ground is not proper, that is why the noise is coming. If I make them not only explaining, if you are able to solve that problem, then you are the proper audio system engineering student. So, all through my lectures, whatever after that I will take the lecture on the board, because I will use some mathematics also. I will describe sound vibration, mechanical vibration, then acoustic wave propagation, all are the mathematical derivation that can be available in the book also. But during the derivation of those mathematical equation, I will explain some physical phenomena towards that mathematical equation. So, you have to clearly know any mathematical derivation when you want to derive, you should know why I do this thing. If you do not know the physical significance of that mathematical derivation, then you are not developing your skill. You can remember the derivation and give the exam. But in my paper, even in IIT also, when I take the exam, I never provide any derivation on the end term papers, because derivations are available in the books. But same derivation, how you use that derivation to solve the practical problem is the skill. So, I may use mechanical oscillation, but suppose in mechanical oscillation, if you are not able to explain why, if there is some two bumper, why there is a speed limit is mentioned, then you have not heard that, you have not done that mechanical oscillation course. So, if you understand the mechanical oscillation clearly, they should be able to clearly explain why before any bumper in the road a speed limit is mentioned. What physically happened if I cross a bumper with a high speed. Okay. So, that you should correlate with the mechanical oscillation. If you are able to correlate, then you understand that things. Okay. So, this is my first lectures to motivate you and provide you the what should be the course coverage of audio system engineering. Okay.